Hello, and welcome to Infrastructure Climate Risk Assessment, featuring the PIVC process. My name is Kurt Hull. I will be introducing this session and introducing Jeff in just a minute, but Jeff O'Driscoll is going to be the very knowledgeable and entertaining presenter for our course. Now, this course is part of the Manitoba Climate Resilience Training Project, which supports the Climate and Green Plan's vision for Manitoba to be the most climate resilient province in Canada. The MCRT project is a cost-shared project supported by the Manitoba Climate and Green Plan Implementation Office and by Natural Resources Canada through its Building Regional Adaptation Capacity and Expertise, the BRACE program, which is part of the Pan-Canadian Framework on Clean Growth and Climate Change. Before we get started, I'd like to acknowledge that Engineers Geoscientists Manitoba acknowledges that our offices are on Treaty 1 territory. We further acknowledge that Manitoba shares the traditional territories of the Ojibwe, Cree, Oji-Cree, Dakota, and Dene peoples, and is the homeland of the Métis Nation. We acknowledge the ingenuity, science, trades, and technologies of the first people of our province. History tells us that those first people took care of the land and developed unique ways and methods of design to survive in our province's harshest conditions. We acknowledge and appreciate their role as Manitoba's original engineers and geoscientists. Now, our presenter today is Jeff O'Driscoll, professional engineer. Jeff is a leader in assessing climate change resilience on infrastructure and holds the designation of Infrastructure Resiliency Professional, or IRP. Jeff is a civil engineer with 30 years experience in engineering consulting. Jeff completed the first project applying the PIVC protocol climate risk assessment process that was developed by Engineers Canada for the City of Portage-la-Prairie Waterworks infrastructure. And since that time, Jeff has worked across Canada and internationally on climate change resilience projects. So with that, we'll get some housekeeping out of the way. Now, this course is being recorded. Hopefully you got a little message there, and your participation confirms your agreement to that situation. Now, we've got, we're asking, or we've got your cameras and microphones off, but there will be opportunities for feedback and for sending questions our way. Throughout the presentation, there's a couple of opportunities for your feedback through polls that we'll be presenting. And throughout the entire presentation, the chat will be open, and I'll be monitoring that. That's sort of my role as we go through this. And Jeff will be ready to answer your questions through the chat. And if you have a question or comment, want to send it through the chat, address it to everyone. But if you've got technical issues, you can select NGGOMB as the recipient of your chat message if you've got some technical issues, and JAMA will help you out. And at the end of our session today, we will be sending out via email a survey with a few important questions that'll be very useful for us. And you'll also get some details, copies of the presentation and handouts. So with that, I'll let Jeff take it away. Jeff.
Well, thank you so much, Kurt, and good afternoon, everyone. In Manitoba, it's afternoon, just afternoon here. And I'm going to be sort of guiding you through for the next hour and a half or so, an understanding and application of this PIVC process. I will explain what PIVC means and its fundamentals and all the bits and pieces of that as we go. So today's course really is just an overview. I'll start off with highlights of previous courses. We did have some foundational courses we hope you took en route to this course. I'll talk to you about what a climate change resilience assessment is and why we want to do them and where we can apply those. And I'll use an example project in Manitoba. I've created a project to guide you through how an assessment is done. So it's an artificial project. And really, this is a process that is enhanced by learn by doing. So I'll show you how, hopefully you have some relational pieces to guide in your understanding. And then I'll get into the steps of this assessment, which is defining the scope, obtaining climate data to do a climate resilient assessment, assessing the risk, and what do we do with that risk? And then finally, we'll have some question and answers in this session. Just for your information, through the hour and a half, we'll guide you, we'll clear out some of the chat and then close this session out. We are going to hang around for time after this for some additional questions, and we'll open some mics up and give you an opportunity, but the formal part of the course will end at 1:30 Manitoba time. So as indicated, the course will walk you through a climate change risk assessment using the PIVC process, and it'll demonstrate some bits and pieces of how climate data is obtained and used in assessing and managing risk, how that can inform design parameters, how to communicate those changes. And really that's what this course is all about. It's an introductory course, and we'll give you some ideas moving forward. And overall, sort of the why, Manitoba's climate is changing. We're experiencing that, we see that with the variation in climate. We see that in terms of greater extremes. And overall in Manitoba, we're getting a picture moving forward into the future with warmer and wetter winters, longer and warmer and drier summers. We saw that this year. Greater variability in precipitation, a lot of dry periods, all the rain coming in, and long high intensity events, and just overall greater intensity and frequency of heat waves and cold snaps, droughts and floods and intense storms. Just really a magnification of our current climate moving forward. And that those changes in climate will have a lot of impacts in terms of, very, very important things that, we'll have increased flood and drought risks. Warmer winters will change the north in terms of winter roads, ice, access to communities. And overall extreme weather is very costly in terms of its impacts to insurance and just the energies that go into disaster relief and a variety of things. And we've seen so much of that in terms of things. In terms of this MCRT program, the association, Engineers Geoscientists in Manitoba was part of a suite of courses. So there's a large offering of courses of which we focused in on a number. And ultimately through that website, you would have registered this course and move forward in terms of things. What we thought, as we move forward into sort of courses that were really geared to engineers and infrastructure decision makers, we thought that there was a number of foundational courses that led up to this risk assessment course, as well as the future courses offering the upcoming weeks of Introduction to Codes and Standards, as well as Nature-Based Infrastructure Solutions, the three sort of suites of courses. But we thought really a foundation or understanding would aid in your understanding today. So a Climate Change 101 course, which spoke to just the fundamentals of climate change, global climate models, how the Earth's temperature is changing and the effects, as well as a Manitoba climate change, sort of the snapshot in terms of how climate may change in Manitoba, some featuring and discussions at the Prairie Climate Center, the Climate Atlas, and a variety of resources. Prior to this course, just the fundamentals of a climate risk principles course was delivered by Dillon Consulting. They did a great job of talking about what the purpose of risk assessments, different tiers of risk assessments, applications of risk assessment. And today will be a little bit more of a deep dive and focus into that. In addition, we thought it very important as a foundational course to look at some of the Indigenous related offerings of Two-Eyed Seeing and climate change in Indigenous communities. So much of what we do and how we act as engineers will be very much affected by a greater knowledge of that and incorporating that too. And then finally, just a course on communicating climate change. How do we see the importance of that? How do we work within our current work streams and offerings to move that forward? So that's really the snapshot of this program and this course path that we recommended in terms of things getting you to where you are today. And what we're going to do right now is just to kick things off, we're going to launch a poll just to get a little bit of insight into your understanding. So we'll leave this open for a few minutes and hopefully you can talk. This is about climate impact. So what I'm really interested in, which of the following climate impacts are the most relevant to your area of work. So I'm going to leave this up here for a bit and just kind of see what your thoughts are for the day. And I can see on my screen as people are answering and more participants are coming through that there's a variety of answers in here. There's no one right answer, by the way. So we'll give it a few extra seconds here. Just hold on, keep answering. I see about 70% of the participants have been answering. And what we'll do right now is maybe give you 10 seconds and we can maybe start to close the poll now. Okay, so I'm not sure if you can see the screen, but really we have in terms of climate impacts based on our attendees today's course, we're seeing a variety of things from extreme heats to extreme colds to extreme rainfalls, heavy snowfall, ice storms, and drought impacting our areas of work or your areas of work. And I'm not surprised, at different times, each one of these hazards or events can be very important. So I don't think we can just pick one. And in Manitoba, we're blessed with this great cornucopia of extreme events that we have to deal with, as well as many other places in the world. So, but that's good to know that you're starting to think of that. And what I'll do now is we'll start to translate that in terms of next steps in terms of the program. So thanks for your contributions. Okay. So if we can close that out, and then finally. So really what I wanted to start and get into the fundamentals here is the discussion in terms of the PIVC process. So I'm not sure if you or many of you understand what this is. It's a product that's been on the streets for quite a while, but the PIVC process, it's a risk assessment process, is a systematic process to assess historic climate and project, the nature, consequence, and likelihood of future climate changes and events on infrastructure, to inform planning, design, operation, and maintenance. So it's a risk assessment process. It's geared towards infrastructure. There's a number of other processes that do assess risk, but this is a fairly detailed look in terms of things. And it really tries to find the zone, if you look in the graphic on the right, of the interaction between infrastructure and climate. Where there's exposure, is that interaction, a wind on a building, extreme heat on a piece of infrastructure. How does that affect things? Is that interaction, have low risk or high risk? And ultimately, when we know those things, we can start to project some idea of what to do with that. But the PIVC process was originally developed by Engineers Canada, and PIVC is really just a summary of an acronym for the committee that developed it. So if anybody wants to know what PIVC means, it's the Public Infrastructure Engineering Vulnerability Committee. And they named the process after those persons that put that together. And I would say that, that committee was struck, going back about 15 years, where they did a lot of the development in terms of this on this tool. So currently, the PIVC program is no longer with Engineers Canada, but ownership and control of the program is through a partnership consisting of the Institute for Catastrophic Loss Reduction, ICLR, and I might refer to that later in the presentation, Climate Risk Institute, CRI, and German, Economic and Climate Change Outreach Consortium that takes care of the protocol GIZ, their summary, internationally. And PIVC, there's a number of products, the PIVC protocol, a more recent high-level screening guide, which I'll talk about later, a portfolio guide, as well as an infrastructure resilience professional training program, an IRP program with a much more intensive training on this. So today's course is just a little introduction to PIVC. It will show you the process, give you some tips. Ultimately, if you want a greater understanding to move forward in terms of how to utilize the tool and have greater competency in that tool, CRI, the Climate Risk Institute, offers a number of training programs for IRP training, whether you want to be designated as IRP in the future or just take the courses for your purposes. Kurt, any questions at this point? Anything on the chat?
Actually, Caitlin just asked an interesting question. How does this model take into account non-traditional forms of infrastructure, for example, stormwater design, considering rain gardens and bioswales?
Yeah, I'll get into that later, but we do have different types of categories of infrastructure, from very hard infrastructure to soft infrastructure to nature-based infrastructure. So we can assess all of those in terms of things. So we'll talk a little bit about that later. And the high-level screening guide, which has just been prepared through the ICLR and CRI, speaks to a lot of that as well. So, okay. So, fundamentally, in terms of the PIVC process or other processes in terms of that, why do we assess risk? And in terms of infrastructure and infrastructure planning, we need to assess risk to deal with uncertainties of the future climate. We have projections, we have ideas of the direction of change, but we really don't know absolutely the fluctuations. We can't tell you what the weather is going to be like this Saturday. So how can we tell you what that weather event will be in the future? But there is a big difference between weather and climate. So there's a number of different fundamentals that we need to understand there. So why do we assess risk? We have to deal with the risks of physical infrastructure, service and disruptions. Ultimately, there's a level of service. A road needs to be open, a bridge needs to be open. We saw the Coquihalla Highway get devastated by that rainfall events in the fall that disrupted service for extended periods. We need to protect people, property, environment. We want to understand how things like wildfire, extreme heat affect populations, affects our infrastructure, affects a variety of things. And although we're looking at this through an infrastructure lens, ultimately this is about how it affects people, populations, communities. We need to consider legal, financial, life cycle costs and management. There's a due diligence. We hope that our infrastructure managers are considering these hazards and making good decisions. And we need to, because of all these challenges, we need to prioritize actions to adapt to them. There's not an unlimited supply of resources or capital, and we need to make sure we're putting the best dollars forward and the best energies forward. And really, we need to change the way we design, build, and manage infrastructure moving forward. The climate of the past is no longer something we can count on. So a lot of our code standards, design practices need to be altered moving forward, and we need to take a risk-based approach in terms of how we do that. And ultimately, we need to be more sustainable and more resilient. And really, to understand resilience, resilience is a lack of vulnerability. So if you're highly vulnerable, you're not resilient. But if you have low vulnerability and you can find that out through risk, that's where you understand if you're resilient. So it's really sort of those concepts that need to move forward. And when do we assess risk? And in the confines of a community, in terms of infrastructure, in terms of public infrastructure, private infrastructure, we should be assessing risk at all parts of the life cycle of the project, in the planning phase, the design phase, the operation phase, and then the upgrading phase where we look at things into the future, we repurpose things as well. And this falls on sort of an ISO framework of risk assessment principles, which one component of that in terms of things is sort of a risk assessment, risk identification, analysis, and evaluation process. And that's really where the PIVC fits into these frameworks. And these ISO frameworks can relate to companies, to government, to operations across the board. So they're not necessarily infrastructure based, they're really operational in terms of many industries and applications. So why do we worry about the future climate? Why do we worry about these changes? Once again, we have to look at the life cycle. And as infrastructure managers, infrastructure designers, ultimately, each piece of infrastructure has a life cycle, sort of how far into the future we expect that that infrastructure will last, perform as well. So if we have things like dams, water supply systems that look 100 years into the future, underground piping systems that look 100 years into the future, bridges, and a variety of things, we need to understand what the end of life cycle climate is in terms of assessing that in today's terms for buildings or for a variety of things. And at 100 years, we don't take that down. It's not, it doesn't expire. We repurpose it as well. So we need to understand these future time horizons in a good capacity to understand how we move forward. And those ideas of life cycle will help you into the future of your assessment to understand what timescales you need to look at, near future, far future in terms of climate change. So what are some applications of a climate resilience assessment? In terms of true applications, right now, Infrastructure Canada's Climate Lens has a component of a climate risk assessment and utilizes PIBC as one of the options in terms of that. And that'll affect a lot of communities, municipalities in terms of funding. Infrastructure Canada has a number of funding programs over the last couple of years that requires this sort of climate lens, looking at things, as well as provincial requirements and other municipalities that are adopting a similar approach. In terms of First Nations, there's an infrastructure resiliency toolkit utilizing the PIBC process. And many asset management programs are starting to take a true look at climate risk and embedding climate risk principles into their asset management programming. Ultimately, in operation and management, we need to understand climate risks and assess things just to understand how we should manage. And a lot of the response to hazards is through operation and standard operating procedures and things, as well as we might need to look at asset portfolio and assessment in large assets, in large categories of assets, say a whole highway network, a power grid, or a variety of things. In terms of newer infrastructure, at the concept and preliminary design stage, we want to assess risks just to see what and how future climate may affect the design parameters and start to look at future climate for changes in terms of a variety of things from extreme temperatures to frost cycles to snow loads and a variety of things that affect our infrastructure. And to look at green and natural infrastructure assessments as well. And that was a little bit of the question on things that we don't have to look at only hardened infrastructure in terms of assessing risk. We can start to look at green and natural infrastructure, these kind of bioswales, stormwater management processes that we're really looking at in terms of being more innovative and softer solutions than traditional hardened solutions of, bigger pipes and more capacity. Companies are starting to look at their climate risks in terms of financial disclosures. We look at emergency management as these hazards have a real component of how communities react, as well as just overall, frameworks of understanding in terms of ISO requirements as discussed previously. So the applications are pretty endless in terms of climate risk assessments. And I think that, it's not a new concept anymore, and being proficient on this is very, very important. So in terms of the PIBC process, and I'm going to start to get into some details and then very soon talk about our project. The PIBC process is a risk assessment process and really has a fundamental of 5 steps. And that's really a number of risk assessment processes are similar, but really where the initial steps are, what are we looking at defining your project, getting information on the infrastructure that we're assessing, to do that both on what infrastructure we're looking at, the degree and magnitude of that infrastructure, as well as climate data, hazards, modeling, other information. Once we have that information, we start to look at those interactions of climate on infrastructure, and that's the risk assessment. When we finish the risk assessment, we start to look at some of the details. Sometimes we need to do a little bit of further study and a little bit more work. We'll call that an engineering analysis. But quite often, a lot of high-level studies, we just look at that risk profile and we start to categorize the risk and move into some recommendations and next steps. So the PIBC process in concept is very straightforward, but there's a lot of detail in each one of these steps, and that's what I'm going to guide you through as we move forward into the remainder of the presentation. And to start off with, to aid in this, and I've been involved in other training projects. The use of sort of a case study or an example project I'm calling here is very important. So what I'm going to do is not just talk to you about the steps, but show how they're applied in a typical type application. And hopefully this helps you with that. So for today's purposes, I've made a project or created a case study or an example project around highway number 10 near the town of Minnedosa. Many of you from if some of you are from Winnipeg, like myself, driving out to Clear Lake or working in those areas or recreation in those areas, we go past this part in our day-to-day works or in our summers or winters. And it's really just a section of highway around there. And I'm just going to show you a few aspects of that. And really, this would be the idea of us getting together and how an assessment would be done. So the example project is really how, say, a Manitoba Infrastructure or a municipality or others would attack a project, maybe hiring a consultant to guide through the process once you've decided that you want to create or take on a climate risk assessment. So this is Highway 16. Hopefully some of you have been through there. It's a beautiful country. Went out there in the early fall, took some photos, and just to kind of have some idea where you're at. With the aid of Google, thank you, Google. You can kind of see this area. It's highway number 10. It crosses the North Saskatchewan River, and the community of Minnedosa is just to the east. Minnedosa is a beautiful community in terms of, it has a lot of historic downtown, and as well as it has some major industries. Husky is there, as well as some other grain terminals. It has rail that goes through there. It has a variety of other things. And really what today we're looking at this is in terms of different categories of infrastructure that we would assess. So for the project, we'll be looking at the highway, the bridge, some community infrastructure, as well as a building. But here's some just general ideas if you haven't been in this region to see. It's a multi-lane highway, highly controlled. There's a fairly simple bridge there. There's a number of different aspects of transportation that we need to look at. We have the North Saskatchewan or Little Saskatchewan River, that winds through there. It's very beautiful. That is really kind of tucked in through the community. We've got this, a number of buildings and infrastructure that we could assess in the community, from public infrastructure, water treatment infrastructure, infrastructure that helps maintain the road infrastructure through Manitoba Infrastructure and Highways, government buildings for a variety of reasons, as well as rail. So we have a whole host of different infrastructure that we're looking at as well. So when we're approaching a project and we start to scope out a project, we have to determine what we're looking at and how. So for today's context, I'm going to guide you through as if we were part of an assessment team, and you're going to watch how an assessment is done. A typical assessment, though, would have a number of individuals, or can have a number of individuals, depending on the scope of how we do the climate risk assessment. And what are some of the team resources required? So if you are saying, okay, I'm Manitoba Infrastructure, I'm a Department of Highways in that region, what would I need? Well, I would need somebody who on this assessment team that would understand the risk assessment process. I would need somebody that has some idea of climate so they could get information. I would need some subject matter experts, either planning, technical, or professional engineering, that know how this infrastructure is designed or operated. I would want to maybe bring in, depending on the nature of the assessment, some natural environment subject matter experts. I would definitely want to have operation and maintenance people involved in the assessment, because they really understand how infrastructure responds during all of these other events we've had in the past. Might need to bring in some managing, legal, finance people, as well as in a lot of cases when we're doing assessments and looking at things, we might bring in non-party stakeholders. So, community groups, other associations as well as in Indigenous consultation and stakeholders that we might want to look. So the team can be large or it can be small. In a very simple assessment, this could be a small handful of 3 or 4 or 5 people. In a large assessment, as you can kind of see in this project, this was for a community in just outside of Vancouver. This where we had 30 or 40 people in terms of the assessment and workshopping to contribute to a risk assessment. So really that's the initial point in terms of understanding. And so the rest of the presentation will be taking this highway number 10 example and walking through the process. Kurt, anything in the chat? I don't see anything new popping up.
Nope, we don't have anything new at this point. But,
Okay.
yeah, thanks a lot.
Okay, so with that that introduction and understanding this process, I'm going to start to step you through the risk assessment process, or the PIVC risk assessment process. So the initial step one of the project, is a project definition. Really, this is a scoping exercise. And this is where you establish what we're looking at. So what infrastructure are we looking at? Because there's so many different categories of infrastructure. This can be done on an airport. This can be done on a building. It can be done on a university campus. This can be done on a roadway. This can be done on a stormwater system. This can be done on sort of an urban canopy. This can be done on active transportation. So there's a variety of things. So what are we looking at, and what is the geography? What are the climate information we're looking at? What type of hazards or typical things, sort of the slow onset climate change or quick onset in terms of things? How far into the future are we looking? We're looking at current risks as well as mid-century, farther century risks. And really, what are the geographical settings? Where is this located? Is this in a community, or is this in multiple regions across an area that could have different climate, as well as who owns this, who manages this? Jurisdictional considerations have to be considered in terms of understanding the risk and action related to that risk. How do they take steps? So in terms of this project, and I showed you some pictures, and hopefully you have some general idea. What we could look at today, and I've broken this down into a fairly detailed, comprehensive risk assessment, where we would look at 4 categories of risk assessment. Now, for today's purposes, we're not going to go through all of this. This would take many days and many weeks or months potentially to do this in detail, but today we'll do a few snippets. We can look at a highway, or in that highway area, in that number 10 highway. There's also a bridge we could assess in more detail. We could look at the adjacent community infrastructure as a whole, or we could look specifically at a community building in terms of a risk assessment. And depending on our objectives of this risk assessment, we may do some of this, all of this, or very specific amounts of assessment. So when we define the infrastructure, if we look at this highway, what we do is we try to break the infrastructure into its various components. And in a high level assessment, maybe we'll have this, a dozen, 15 or so assessments. In a very detailed assessments, we can have a lot of categories. We could have tens and tens of different aspects or unique attributes that we could look at. But in general terms, for illustration today, something like a highway, we'll look at the road surface, the pavement structure, the embankments. We'll look at the drainage, which would incorporate culverts and ditching and a variety of things. And then we'll look at some of the highway safety measures that we look at, the operation and maintenance. And we actually assess the operation and maintenance typically in these risk assessments, because the response to a climate event is so heavily involved in terms of how things are maintained. We'll look at other life safety stuff like guardrails, signage, and lighting. So that's how we would assess this highway. Now, depending on different highways and different objectives, you could have different things. In terms of the bridge, we can assess it for the bridge structure, superstructure, the deck, joint bearings and drainage, safety for railings, maintenance again, as well as the river in terms of, ultimately the Little Saskatchewan River. We could look at this in terms of, a number of concepts, just in terms of flood stage, how it affects the bridge, but we could look at it in terms of the riparian areas, environmental considerations, water quality, and a variety of things. In terms of the bridge, we're more focused in terms of the risk assessment on the hydraulics in terms of how it affects the bridge. Adjacent infrastructure, we could look at a number of other assets and a variety of things, as well as the building. And in terms of a building, we have a lot of different things to look at in terms of the building envelope, roofing, the foundation, HVAC components, building controls and automation, life safety systems in a building, the plumbing systems, lighting systems, communication, security, electrical, and drainage, site, parking considerations. And you can heavily expand on all of those. You could do windows, you could do curtain walls, you could do structural elements, you could do a variety of things depending on how you want to build that out. So that's really how we define the infrastructure. And a lot of the initial work goes into defining that and then going and getting information on these components. Typically, the information is through the people that operate and manage this, that they have a good corporate history in terms of all those responses. So once we've defined the overall aspects of the infrastructure, we start to move into the aspects of climate. And ultimately, what we want to look at in terms of a climate risk assessment is typically a whole suite of climate change, potential climate hazards, or climate attributes. Now, if we were on a coastal area, we might only look at coastal sea rise, storm surge. We could be very focused. If we're on a river, we could look at just riverine flooding or other aspects. But in a lot of cases, what we want to do is do a whole suite or a whole aspect of different considerations. So those could be temperature-based, average temperatures, extreme temperatures, highs, lows, and a variety of things. Precipitation is rain, so rainfall intensity in terms of longer, wetter periods to dry periods and drought conditions, to average amounts, which may affect things. And, average rainfall things, yearly rainfall may affect different things, whereas it may, in terms of a road structure, it might be more about, say, high intensity rainfall. Precipitation is snow in terms of a variety of things. Events like hail, ice storms, flooding considerations, fog, river ice and ice jamming, frost, which is very important for freeze-thaw cycles, which affects pavements and a variety of other things. Wind in terms of wind gusts, thunderstorm winds, tornadoes, and really high intensity winds. Fire, either fire itself in terms of wildfire or smoke related to fire, lightning, and other hazards. So this is just a sort of a suite. Obviously, in Minnedosa, sea level rise, storm surge is not an issue, so it's not on this list. So what we start off with is sort of a list of potential things we're interested in. And once we understand or have the dialogue on that particular piece of things, we start to decide what information we need. And this is sort of where we would engage or bring in our climate specialist to help us to guide through on information and to go off and get that information. So in terms of this risk assessment for Minnedosa and for these categories of this sort of list of things, I've highlighted a number of what I thought, or the team and this artificial team would have thought would be the things that we would be looking at in terms of an assessment. So when we look at this kind of public infrastructure, average values are important and mean values. But more importantly, we're looking at extremes, extreme high temperatures, extreme low temperatures. How does our infrastructure perform in those areas? Same with precipitation, annualized, and a variety of things are important, but a lot of the frequency and intensity, high intensity events would be looked at, as well as that for snow events. We could look at things like hail, ice storms, a variety of things, as well as obviously this infrastructure goes through this Little Saskatchewan River Valley. We could look at river flooding and information. Now that information would be a little bit more difficult. We'd have to go to either some previous studies, or in a very detailed assessment, we could start to look at some hydrologic projections in terms of flooding and flood details, freeze-thaw cycles, extreme events, and a variety of things. So really what we're looking at in terms of climate is understanding this. So we know, in the previous step, we said what infrastructure we're going to look at. Now we're talking about what climate elements we're looking at. And I'll sort of walk you through the detail of how we actually do that. So like I said, the first thing is just selecting what's important to us based on the objective of our study. So once we have that list of climate elements, we have to decide ultimately what is important to us related to timeframes. And I had a few slides that we talked about expected life cycles of infrastructure. So depending on what we're looking at in here, and if we look at sort of bridges and road surfaces, on a road surface, we might be looking at a life cycle of 20 years in terms of between, upgrades, repaving, overlays, a variety of things. But the bridge itself might be, looking much farther into the future, to the 50, the 100 years in terms of things. Buildings itself, that building that we're looking at looks like a fairly historic building, so it's already has a fairly long life. But with upgrades and repurposing, could we envision it being another 100 years down the line? Absolutely. So in terms of looking at a climate risk assessment and typical assessments, what we tend to look at is a number of fairly standardized slices of time. So the first thing we want to look at is the current climate, which is our sort of current climate data sets. And that's what we'll call the recent past, because those data sets have to be assembled, so they'll be in chunks. So that's sort of where we're looking at. So that's kind of the current climate. We also want to look into the future in terms of sort of a mid-century look, so the 2050 look, and that would be a data sets looking at the future. And now we're into projections, whereas the recent past is actually recorded climate data. Into the future, it's not data anymore, it's projections. So we start to move into in some understanding of the use of global climate models to establish information related to different time sets. So the 2021 to 2050, that data set we'll call 2050, and then we'll call that the mid-century. We also want to look at, for this assessment, a farther view into the future up to about 2080, and that's a data set of 2051 to 2080. So those timeframes are very important, and they relate to how a lot of the global climate models are there in the suite of information that will become available to us. And I'll show you in a slide or two on where we pick that and why we pick those as well. Now, these timeframes don't have to be absolute. You could have different timeframes depending on your infrastructure. You can go even beyond this to the 2100s and beyonds in terms of climate data. But for the scope of this assessment, as if this was sort of something here, we would look at these three timeframes. And we're not yet into scenarios of future climate change, more climate change, less climate change. We'll get into that a little bit later. So we're still scoping out the project. So ultimately, the last piece, the last understanding of where we're at in terms of is jurisdictional considerations. When we're assessing this study, it's important that we understand who owns that infrastructure. In a lot of cases in here, at least in these examples, this is a lot of public infrastructure. So, the province of Manitoba through different departments would manage the roads, the bridges, and some of the public works type infrastructure within those. The municipality may be looking at this. This might be a federal building here or a provincial building and related to legal or other government operations. Or we could be looking at, say, a hotel or the Husky, which is a private endeavor as well. But so those matter in terms of who your stakeholders are, who your decision makers are, and some of the legal and other ramifications. So that's important as well. And geographically, ultimately, where all those sit and who's important. So, Kurt, any questions in the chat?
No, there haven't been any. Oh, something just came in. I haven't even read it yet. Could you speak to the impacts of regulatory barriers for innovation in this process? For example, I understand stormwater is designed as wastewater. At the federal level, I understand this means that only hard infrastructure can be legally considered for liability servicing limitations by municipal governments, and any soft infrastructure would be considered redundant. Would this process result in design specs requiring larger pipes for peak storm flows, regardless of any other overland interventions?
Yeah, I would say absolutely those considerations are in your scoping of your assessment. I think that those details are sort of more related to how you define your infrastructure. I don't think in terms of this tool, we're constrained by those regulatory views on how we build it out. This is more of how that infrastructure manager would like to build this assessment in terms of the parameters. And a lot of the actions of this, once we get into the later steps, how we deal with this risk what are the regulations related to this are probably more about how to deal with the risk as opposed to identifying the risk. This is very much a risk identification process, but all of those other considerations should be in mind as you move forward to an ultimate result. So what I would say is those are very specific pieces, but they can be worked within the confines of these risk assessments. So absolutely, and experienced practitioner using this tool can guide you through those kind of questions and objectives in a study, from very high level to very specific. Okay.
Thanks, Jeff.
So in terms of climate information, and we said, that first step was defining the project. So what infrastructure are we looking at? What climate elements are we looking at? Where is it? What are the pieces? How do we break it down? Now in the next step of a study, so this would be, us as an assessment team. Now we got to go get the information related to the study. So we need to collect data. We need to collect data on the climate. So this is where we go and get actual detail. And this is also where we would go and get information on the infrastructure as well. We would potentially, in an assessment, we would go visit the infrastructure, look at its condition, help to assess that, whether we get drawings and a few other things for that. In terms of defining this, scale matters and the level of precision matters. In a lot of this, the PIVC process, or at least the high level screening part of the process, we can use a lot of readily available data, and it becomes a proxy to other information. We can use, and I'll show you that in a second by going to the Climate Center's Climate Atlas to get information. We can look at relational information to do very, very specific threshold-based climate projections. Downscaling can be very expensive, and it may, in terms of a high-level assessment, may not be required. So we'll try to get through some of that as well. So the level of precision is important in terms of understanding how to apply these. My recommendation on a climate risk assessment is to start high level and then drill into details as you move forward, just to assess your initial risks and then get into the details later. So that really comes into the level of assessment. Today's presentation really gears around a fairly high level first pass of risk and not a deep dive into very detailed risk assessment. So obviously that's really for illustration, just to show you the process. So when we talk about climate information, we're very fortunate to have a number of resources across Canada, internationally, where we look at information. Organizations like Climate West are important to us. ClimateData.ca, the Climate Atlas of Canada, and a number of other resources that we can use. Local information that's already been done. So there's a lot of available climate information to assist in a climate risk assessment. In terms of my go-to, at least in many assessments on the prairies or in Manitoba, my starting point is the Prairie Climate Atlas. And the Prairie Climate Atlas is at the University of Winnipeg, and it's really a service provider that provides a lot of information related to assessments. So in terms of this project and where we're at in terms of things, I'm going to show you a little bit about the Climate Atlas itself. So I'm going to break out of my presentation and go to the Climate Atlas. So remember, we've decided that we want to have a number of parameters: temperature, precipitation, wind, and a variety of things for this assessment on the infrastructure for the current 2050, 2080 timeframes. And where do we get that information? Well, one of the options is the Prairie Climate Atlas. So bear with me while I escape out of my presentation. And I go to the web. Okay, so I'm going to go to Google and I'm going to type in the Climate Atlas. Going to get the Climate Atlas of Canada, and Kurt, you can kind of confirm that you can see my screen. Is that
Yep,
okay?
I can see the Climate Atlas blue page there.
Climate Atlas of Canada. There's it's a great resource. If you saw the climate Made in Manitoba climate thing, they went through this as well. Go to the map. Where's Minnedosa? Where's Minnedosa? Minnedosa is in Westman, in this region. Click on Minnedosa, and boom, we've got a number of climate indices and climate information for our assessment. Going back about 15 years, we didn't have this ability to do this in risk assessment, but now we do. So we have this shopping list of climate elements that we want to look at. The Prairie Climate Center, through this climate atlas, has done a number of projections based on Background Environment Canada data, as well as different understandings of timeframes from the recent past, which we talked about, to the 2050 timeframes, to the 2080 timeframes, under different climate change scenarios. So in terms of less climate change, meaning less greenhouse gases, a brighter future in terms of change, or more climate change, more greenhouse gases, and more influenced climate change being predicted. For the purposes of my assessments, I always use worst case scenario of more climate change. And these relate to different RCPs, representative pathway concentration models, a suite of models in terms of how this data is put forward. So we have indices on weather, where we can have very hot weather, cooling days, extreme days. So depending on your infrastructure, you can pick different pieces of that. If you're in agriculture, you may have different indices as well. Cold temperatures, information related to very cold days, freeze-thaw cycles, a variety of things. Precipitation, from annualized precipitation, one-day maximum precipitations, heavy precipitations events. Now, these may not be the exact thresholds that you may be looking at, but these are great proxies very quickly at a high-level assessment to use. So this is where I get all my data, and I'm going to show you in a few seconds where all that data is. But if we go to something like we can get a full climate report from the climate assessment for Minnedosa, and we get a report from Minnedosa. This is popped out. This is live in terms of things for a number of scenarios. So we talked about more climate change, which is RCP 8.5, a high carbon future. And we look at is a suite of parameters from our current climate to our 2050 climate to our 2080 climate. And if we look at something like very hot days in Manitoba, our current climate says days over 30 degrees Celsius for Minnedosa is about 7. Into 2050, we think at a mean rate, we'll have about 19 days above 30 degrees Celsius, and in 2080, 38. And that sort of mirrors sort of an understanding of the fluctuations in terms of municipalities of definitely a high warming. Look at a lower carbon future, which would have less aggressive things, but for this is a study, I would look at this. So now, assuming that I went through here, gained all the information I wanted, looked at other data sources and a variety of things, this is where I would come in and compare data. So you can still see the presentation back, Kurt?
Yep, you can now. Yep.
Okay, so that's in terms of a climate risk assessment, modeling and gaining information related to an assessment, we do that. So here's that report that I pulled up. Hopefully it's the same, sort of you can't read the details here, but you can see that there's a lot of information and data related to Minnedosa in here. Sorry, some of the granularity in the presentation is not great. So that's where that source of data is. So we're in step 2, climate data, this is where we get information. Now, how this information is used, how to interpret this will be best suited by having somebody with a climate background, climate specialist involved. In very detailed assessments, we might use a climate scientist on our team, or in some cases, at different levels of assessment, we should have somebody with good climate awareness and competency and understanding. So if we look at something like Minnedosa, and although I did talk about these ideas of very hot days, if we look at something like mean temperature, we can look at another set of parameters. So Minnedosa's mean annual temperature currently is 1.4. In 2050, it's increasing 3.7. and in 2080, it's being projected to increase to 6.2. So there's an overall trend of warming in Minnedosa, which mirrors the rest of the province as well. So that's great. We've got all this climate data. We understand our risk, but climate information, climate data, numbers of days above or an average temperature is not easily used in a risk assessment. We have to start to, and this is where the PIVC process informs us, we have to turn this in terms of sort of some ideas of some likelihood scores. So when we get into risk analysis, and that's sort of the beginnings point, risk is the product of the likelihood of event happening and the severity or consequence of these events. And I'm using the language a little bit loosely in terms of risk terms. So in terms of a risk assessment using the PIVC process, we have all of this climate information or flooding information, whatever. We have to turn all of those information into a risk score. And it's a tool, a part of the process to enable us to be able to have a risk score number. And based on that risk score number, we can associate low, medium, and high risks. Okay. So for each one of these scores, there's some methodology and background and guidance in the PIVC process. We would turn some of these scores into, or these climate information, like a 1.4 degrees, we can turn it into a likelihood score. So we'll turn that number into a 3. This is what a climate scientist or a climate specialist would do for you in the risk assessment process. And for each one of these, we assign a different score. Okay. So as we go through each one of these shopping list of climate elements, we assign different scores. So I've gone through, our climate scientist, if this was an actual assessment, has gone through and assigned different things. For annual temperatures, you saw that 1.4, 3.7, 6.2, and a 3.45. If we look at winter temperatures, presently we have about an average winter mean temperature or a mean temperature of 15.8, and it's warming into the future to in 2050 minus 13, to 2080 about minus 10. So these are the projected changes. So we would reduce that. So we have a 3 and a 2 and a 2 in terms of likelihood scores. So we do that for all the hosts of temperature parameters and a variety of things. Same with precipitation, from annual precipitation where we have actual data and we turn those into scores, to something like a high intensity event, a precipitation, heavy precipitation days with 20 millimeters or more, to different scores, to drought conditions, to ice storms. In some cases where we don't have a lot of climate data, we won't always have information. A climate scientist might look and give us some idea of a trend, that there may be more climate change or less climate change influences into the future. So there's some decision making and there's a number of assumptions in a risk assessment. And then ultimately events like lightning, flooding, fire at this high level, the same kind of thing, some decision making related to that process. Okay. So that's the climate information in a variety of things. So any questions, Kurt? That's a little bit gritty and that goes pretty quick.
Well, there's getting to be a bit of a conversation going on in the chat. I'm first of all, Trevor's question, hopefully Trevor, Rena from ICLEI has provided a link to a guidance document on good practices for climate change risk assessment. Hopefully that'll answer your question. I've got a couple of others specific to where we're at here in the presentation, and then Sade, I will get yours at the end, but this is okay. First of all, from Harry, the snowfall this year, would it be considered heavy from historical mean snowfall?
I guess I would want to look at today's data related to that historic data. So I think you'd have to go look at the actual data. I'm assuming Minnedosa, if we're talking about Minnedosa, has had heavier snowfall this year as well. So I would look at it in terms of that assessment. I wouldn't be, I think it's understanding today's events or weather or today's climate doesn't necessarily speak to all climate, because so climate is the sort of whole suite of variety of changes of climate, snowfall, average snowfalls, extreme snowfalls. So that whole picture of climate changes. But it would be interesting to gauge where we're at in terms of the amount of things. We do have natural variation. So it's not like all of a sudden we will get snowfalls in high intensity in Manitoba. So I think my question is, I think you'd have to look at the data in terms of things, but it's very important to get a feel for all that as well. So, okay.
And the other question related to where we're at here is the heating and cooling degree days is also another consideration. I'm seeing, this is from Carolyn, I'm seeing the averages and means.
Yeah, absolutely. Absolutely. So I think depending on the objective of your study, what you're assessing, what's important to the objective of your study, those things are very important. I think when you get into things like urban heat canopies and stuff, those average annual temperatures, summer means do matter a lot. If we're assessing an HVAC system, it's probably less about average temperatures, it's more about extremes. So the climate information you're looking at is based on what you're assessing. But absolutely in the confines of an assessment more focused on that, we'll look at that. I have a little snapshot of that in the exercise later. So, okay. So in the essence of time, and we will have much more time for questions at the back end, I'm going to start to go through some of the steps and I'll start to accelerate this a little bit here. Okay. So now that we've got that climate information, we've established our bits and pieces related to the risk assessment. We're actually in the risk assessment piece. So now this is the core of the assessment. This is where we assess risk. Risk has a lot of fundamental understandings of risk tolerance. So if your organization can assume a lot of risk, you might choose to do less. If you have low risk, if you're, say, in a hospital, you probably have a low level of risk. You can't have power outages, you can't have loss of water, you can't have transportation disruptions. Your risk tolerance is low. We need to find out, if we only look at today's weather, we need to look at future interactions. If we haven't had ice storms in Manitoba, we still in the future may have ice storms. So we don't only want to look at historic hazards. We might have in the snapshot of the future, we may need to look at potentially future types of climate hazards as well. Although, we would have said ice storms or something 15 years ago that happened in Quebec and Ontario. And then 3 years ago, we got hammered in Manitoba with that canopy issue. So you have to look at events. It doesn't just rain. It doesn't just snow. Usually there's a lot of cumulative effects as well that can be built into these assessments. And ultimately, there's a lot of judgment in this. So you just have to understand that this is the process. So those are considerations in understanding risk and fundamentals. Ultimately, risk, and I touched on it before, is in the simple terms, in terms of PIVC, risk is defined as the product of the likelihood of an event. So how often will that happen, that event, and we have that climate data. And if it happens, what is the consequence of that event on that infrastructure or that stormwater system or that urban canopy or that natural asset? So that's the risk. And by using a framework or scales of risks of consequence and likelihood from 0 to 5 in this case, for both, there's other indices 0 to 7s. What we do is we can start to understand the risk score, and a lower risk score equals lower risk. And as we have higher scores, we have higher risks. So some very low likelihood, high consequence events can have medium and high scores. As a variety of things. So in terms of slicing things, this is where we sort of have categories of risk from low, medium, and high. And the PIVC process has these scales. So we see risk scores in the 2, 3s up to 9s, that's low scores. Risk scores in the 10s to 16s is medium risks, and 20s to 25s is high risk. And this process is a summary guiding you through a process to understand how to ultimately address your highest risks. Okay. And the way we do that is in terms of PIVC, is we do a risk assessment process. And in many cases, we use a risk assessment worksheet, where we start to put all of these infrastructure components, those lists that I gave before in the earlier example, and all this suite of climate parameters. And what we do is we go through a formal process of evaluating each one of those interactions. We do that generally through a risk assessment workshop, and it takes many hours to go through all the details. We may have background data as well. So that's the risk assessment process. In terms of today, and a normal assessment process, this is where you would bring in your specialists. They might do an initial risk evaluation. You'd bring in your stakeholders. You might have a workshop in terms of understanding your risk, depends on the magnitudes of this, and you would go through and ultimately understand this. For today's purposes in this exercise, I'm going to pull up a risk worksheet, and I'm going to show you the process a little bit so you get a flavor for it and move forward in terms of understanding risks. But ultimately, what we do in the process is, first of all, when we look at each asset, we have to say, is there some kind of an interaction? Is there exposure? Does rain affect a pavement structure or a pavement surface? And I would say yes. Does average temperature affect it? We'd say yes. And if it does, then you start to score some of these different consequence scores. Okay. And then ultimately you come up with a risk profile. What I'm going to do now is, once again, and I'll ask for Kurt's assistance here, is to go actually pull up a risk assessment worksheet and something that would be something similar to this on a project and show you the process. Okay. So Kurt, if you can sort of give me sort of a heads up that you can see my screen.
Yep. I see. Yep. Looks good to me. Yep.
Okay. So once again, we categorize all the infrastructure. We have now all of our climate information. And what we would start to do is sort of what we'll call a yes/no analysis or exposure analysis. And we go through that. So if we're looking at a pavement structure, so the pavement structure is going to be the asphalt, the base course levels, the geometry of that, the crossfall on that. So that's what we're assessing. So do we think that annual temperature affects our pavement structure? I think that it does. So we would say yes. And if it does, then we would start to score. We would start to score in terms of some consequence. And now if we have, and we're looking at a 1.4 degree day, what is the consequence of a 1.4 degree day on our roadway surface? I'd say that, is it catastrophic, major, moderate, minor, insignificant, or does it have no effect? Well, I would say it probably has a very minor effect. So, work with me on this. So when we score the consequence, we end up with a suite of risk scores, from present risks to 2050 risks to 2080 risks. So what we're saying is, as we increase average mean temperatures into the future, we start to see a little bit more warming that could have effects on the pavement structure. Okay. If we look at summer mean temperatures, we might have some effect as well. Excuse me. And ultimately, probably the same kind of a minor effect. If we looked at something like extreme temperatures, days above 30 degrees, we would probably have much more of a moderate or major effect on our pavement. This is where all of a sudden we would start to affect our asphalt. We would start to affect the mix design. We might have different considerations at many hot days in terms of the pavement. So what we see is, moving into the future, greater risks. Okay. So if we go through all of this in terms of each category, and we start to do a number of things like freeze-thaw cycles, yeah, that affects things. That's very important for roadways, and it probably has a major effect. With future climate change, although instinctively I wouldn't think this, at least the current projections are that freeze-thaw cycles in this region are actually decreasing in magnitude moving forward, although not entirely getting rid of. There'll be a few less. So the risk is being reduced into the future, or the risk is around our current risk. So if we go through all of that, we ended up with a suite of different risks in terms of high, medium, and low risk that we've developed in terms of our assets. So if this process, we're team members, we're going through this, we would see where we're going. So we could and can assess all aspects of bridges and things. If we said in the context of a building, if we wanted to look at the HVAC components, and maybe this is around sort of an earlier question, not entirely, but discussion, something like HVAC equipment, we could look at something like annual temperatures and something like, yeah, that affects equipment. It affects the the operation costs, the overall life cycle of the building. So that has a moderate effect. If we look at something like extreme temperatures, and like I said, you would flow all these out, extreme temperature on an HVAC component, I think that has a major effect. In the future, with many more days over 30 degrees, is our ability to cool the building there. So it does affect our HVAC systems and a variety of things. So if we go through as a team, we would have different specialists. We would have operations telling us how things are. We would have the designers who talk about the equipment. We would be able to come up with these collective consequence scores and therefore the risk. So after many hours or different workshops or different stakeholder engagement sessions, we would come up with something that would be something like a completed risk matrix for this whole assessment, and ultimately have some idea of the risk profile of these assets that we're looking at in terms of things. So if you look at buildings, we would see that extreme high level or extreme days or heat waves affects building envelope, roofing, HVAC components to high degree, and a variety of things. We see that things like high intensity ice storms can affect life safety systems, as well as building controls, transportation, obviously as it relates to parking and site and drainage, and things like electrical can be affected by fire in terms of the service, as well as HVAC components could be heavily affected by smoke related to fire. Okay, so that's that. So ultimately, when we complete this, we have this whole risk profile, and that's our risk assessment. Okay. So any questions on that? I went pretty fast, and ultimately, my apologies. That's the nature of this process, is we're just kind of giving you a snapshot. So this risk assessment process is the heart of the process. And as you go through this and go through these parameters, it's sort of a HAZOP type desktop exercise with engagement. You can do this very, very limited amounts or to greater amounts with lots of engagement. My recommendation is you should have a minimum level of people that have an understanding of climate, understanding of the infrastructure, as well as the understanding of how the infrastructure has responded in the past, which basically usually is around operation and maintenance. And then you can bring in other stakeholders. So, okay.
Yeah, okay, we got a couple of questions related to where we're at right here. There's actually getting to be quite a few questions.
Yeah.
I don't want to put you on the spot, but there's a lot of interest in your spreadsheet. Do you think we'll be able to provide a copy of the spreadsheet as part of our follow-on?
Yeah, absolutely. And remember that this is not an actual example, and this was done by me, not with actual subject matter experts. All of this process and these tools is available through the climate risk or through the ICLR website, pivc.ca. I'm going to get to where you get all this, including the templates for the worksheets, the processes, where to get the climate data, and all the steps. So the high-level screening guide, which just the PIVC high-level screening guide just came out. So the answer to this is yes, all of these resources will be provided in terms of direction moving forward. Hope that helps.
Great. And that is a reminder for those who are participating here. In order for us to be able to send you the survey and the slides and the whole bit, we need you to change your name so that we can keep the roll call. And in the chat right up at the top, there's a means for how you can change your names, because we're monitoring who's on the call so that we know who to send all this information to. So that's a good segue into that.
Yeah. So I'm going to maybe hold some of the other questions to the end, Kurt, because we have.
Let's do that. Okay.
Those that need to leave at 1:30 will be finished the presentation, and then we'll have quite a few minutes of additional time to clean up the chat or directly take questions. Okay.
Thanks, Jeff.
Okay. So once we go through that risk assessment process, we filled in this risk profile of the whole thing. When we look back away, you can't see the numbers, but you can see the colors. You can kind of see this is the risk profile. You can see all the white areas are areas of low risk, the areas of yellow are medium risks, and the reds are high risks. You can start to see the trends. You can start to see the areas which affect aspects of the infrastructure. And now we can get into the risk, the analyzing the risk and evaluating the risk, which is the next step in the process. So the heart of the risk identification was the risk assessment. Now, what do we do with that? Okay. So ultimately, in some cases, after that risk assessment, we want to do a little bit more engineering work or technical work. But in most cases, we skip that step. This is that engineering analysis. And we move on to, okay, what do we do with these risks? Okay. So first thing we do is we try to summarize these risks into these high, medium, and low, which is those colors. And we review some of the why we scored these consequences. And we begin to develop some actions related to what to do. Okay. So once we've identified those things, we kind of start to move into the recommendations. What do we do? In terms of PIVC, they give you a little bit of guidance in terms of next steps of understanding some risk mitigation action things. Okay, let's do something about those risks. We can, move something like avoid, we can protect something, in terms of like you see in the graphic with a dike or natural infrastructure on a wetland or something to control peak or flooding or other aspects. Or we can accommodate things. We could raise things. We can do a variety of things. So there's a number of things we can look at. In this risk mitigation, we would want to look heavily at natural infrastructure solutions. And that speaks to the course that we're going to deliver in a couple of weeks, as well as things that we want to look at in terms of mitigating for future climate on new standards, new codes, new practices as well. So if we're going to do something, here's some feedback. In some cases, then low risk, we take no action. We're good. There's still risk, but they're low. Let's pay attention to something else and come back and revisit that in the future. Remedial action, we might want to take some other steps. Management action, we might want to increase the frequency of maintenance. We might want to observe things differently. We might want to get more equipment to clear roads or to do a variety of things. Or in some cases, we're not sure. We have to do a little bit more detailed work in terms of stuff. So that's around the recommendations, okay? In terms of our project, and once we looked at some of that, here's a couple of things, some ideas of how an example in this example project, how we went to that. So on the pavement structure. So based on that risk assessment, if we had done that as a group and the findings, we would see something, related to the road that, medium risks were noted in the near and far future at extreme high, low temperatures, high intensity rainfall events, winter precipitation, ice storms, and wildfire smoke, and high risk were identified in extreme heat and ice storms. So there's caution in terms of a lot of those other parameters, but definitely in something happening in the future related to extreme heat and ice storms. So what would we do about that? So in terms of, we would have a dialogue with Manitoba Infrastructure, and this is once again an artificial project. We would think that we probably need to do a couple of things, some remedial action and some further study. So something like Manitoba Infrastructure review pavement design structure for increased temperature impacts the surface during ice storms. So what I mean by that is they could maybe start to study how that mixed design could be a change or effect in the future, and maybe in a future upgrade to highway number 10 in that region, they might do some adaptive measure of using a different mixed design. They might change the pavement structure at that upgrade as well, or they might have to do some remedial action later to enhance that as well, to see, because that temperature increases or those increases in temperatures might affect the pavement durability and life cycle. In terms of ice storms and things, well, that's probably more about the surface, an extreme event. It might be related to how they act in terms of operation, maintenance, maybe where and how they do icing prevention, maybe where and how they might close a road based on operating procedures and a variety of things. So that's the outcomes of this in terms of a variety of actions. If we looked at something like HVAC components, which is a whole different category in a building. We'd see something like medium risk for noted in the near and far future related to average temperature increases and extreme high and low temperatures, high intensity rainfall, winter events, ice storms, lightning, and smoke. High risk were identified in extreme heat and wildfire. So what would we do? So same kind of thing, remedial action, and we might want to look at it in greater detail. For HVAC upgrades, to consider future extreme temperatures. So when you're you've got a life cycle of about 20 years on your infrastructure, the next time you upgrade your systems, you may have to put in larger cooling capacity or something. That's a very hardened look at it. We also, for more wildfire smoke, might need to have more air exchanges. So, but also over and above this, the building should consider additional insulation potentially, so we don't need as much HVAC, increases to shading, urban canopy, other natural-based solutions to maybe mitigate that, or also to reduce the level of service and say maybe on the very hottest days we could accept a hotter temperature in a building. So there's a variety of actions that could happen in terms of the actual remediation. So once we've done that, once we've put together all of those actions related to that, we really kind of finished the risk assessment in terms of things. So risk assessment is very good at identifying risks and starting to point in the direction of what to do. But ultimately, adaptation planning is the next step. Some detailed adaptation, what to do, and the principles. So really, those next steps could be further risk assessments on those high and medium risks, more detail, more granular information, more threshold-based information. Or we could just go in terms of informing concept or planning phases in terms of, okay, go do something about this. We could have this suite of considerations and hand that off to the design team if this was a new build or an upgrade. We could inform operational practices, capital planning in the future, and a variety of things. And then ultimately, when we finish these assessments, we need to communicate this. So we need to generally communicate this to operations, decision makers, sometimes councils. And we tend to do this in reports, presentations, and a variety of things. We might need to create a return on investment, business cases in terms of analyzing things. We might want to now look at problems or risk mitigation through triple bottom line analysis and a variety of other aspects in terms of next actions. So we're kind of at the last stage here, and now we're going to launch our final poll. So if you can see that, I'll give you a few seconds. So the poll that we'd like you to engage here is, so where can a climate risk assessment be applied? And feel free to choose more than one. So I'll give you a few seconds here. And you can also scroll down to see some of the lower answers. And I'll give you a few more seconds here. But ultimately, and we've got about 60% participation. I'll give you about 5 more seconds. And Gemma, let's close the poll. So we can see across the board that, I think we can use these climate risk assessments in a variety of aspects of infrastructure planning and decision making. And I think really this idea of risk-based thinking, risk-based analysis should really be incorporated into most of what we do moving forward. So I'm glad to see that there is a really good distribution of answers across and as we move forward. So thank you on that. I just want to, we've got just a few more minutes. We've got about 6 more minutes. What I see just to end the presentation here is to just talk to you about this process, the PIVC process. And although the PIVC protocol has been on the streets for about 15 years, in recent times, I was fortunate to be part of a working team that put together a new high-level screening guide, a little bit more of a process about what you saw today. And this can be found at pibc.ca. And this is sort of a more of a quick and dirty guide on how to do these risk assessments. A lot of tips in terms of resources, where to get the climate data, how to break it down, examples of how to break your say a water supply system down into components and temperature components, climate reports, and tools like risk worksheet templates and a variety of things for you to move forward, as well as a number of case studies just to show you how things are going in terms of the PIBC. So the PIBC process is very powerful. It's been used in across Canada, internationally, in most public and private infrastructure components, and I really encourage you to move forward. Go to that site, register. I don't think there's a cost. Well, there is no cost. Just register and start to apply this in terms of your projects. And I think this is where, Kurt, if you want to, we can start to talk about next steps in terms of the presentation. First of all, thank you everyone for your patience in terms of this process and understanding the PIBC process. We really encourage you now to register, if not already registered, for the next courses developed by Engineers Geosciences in Manitoba. Introduction to climate change through codes, standards, and regulations. We've got a number of subject matter experts who put together a number of categories in terms of things. We've partnered with Red River College, Polytechnic, who have put together a lot of good content and subject matter experts. And it's a really good picture of what we'd be looking forward in terms of, okay, designers, how do you tackle climate change through these aspects? In addition to that, we have, this course, PIBC, is about identification of risk and initial steps into risk actions or adaptation actions. So our final course is nature-based infrastructure solutions to enhance resilience. Okay, let's get out there. Let's look at opportunities, understand what nature-based infrastructure is, how it can be applied in some case studies. And we've partnered with IISD, the International Institute of Sustainable Development, through some of their work to put that course on. It's very strong. We've seen pilots about these courses, and I really encourage you to move forward to that. So,
yep, that's right. And that nature-based solutions course might fit with the question that Caitlin asked earlier, and maybe some of the others. That's coming up on February 23rd, Wednesday, February 23rd. And the course on codes is coming up on Wednesday, February 9th. So in a couple of weeks from now.
Okay,
and
might have some different dates here, but we'll check the MCRT course listing for actual dates. But yeah.
So just before, we only have time for maybe one more question or maybe two before the official end of the half hour. And I'm going to start with the last question, which is from David. How does the First Nations Infrastructure Resiliency Toolkit differ from this?
Yeah, okay, that's a great question. So I think the process is relatively the same, but it's founded more on the asset or the acres system. So a lot of the First Nations community already have an asset inventory called their acres system. So it builds upon a lot of that existing work. So a lot of the components are already identified in terms of those asset listings, sort of an asset management kind of thing, as well as it has a lot more related to Indigenous content, maybe engagement, as well as aspects of local knowledge, Indigenous knowledge in terms of, I would say that idea of two-eyed seeing, like the course we put on. So the framework was the same, the processes are the same, it would be very familiar, but there's a lot of aspects building on what's already there at the community levels, as well as really prioritizing the engagement at the community level for the decision-making and identification of risk, as well as the actions related to the risks that are very viable and significant to the communities. So it's important. So hopefully I answered that question.
Not sure we'll have time before the half hour for another question, but maybe if you want to wrap up there, Jeff.
So thank you very much on behalf of Kurt, myself, Engineers Geosciences in Manitoba. We hope that you enjoyed this course. Thank you everyone for your time, and we're going to close the presentation. We're going to take a bit of a pause here so we can sort of stop the official video, and this will be available to others eventually through the MCRT site.